Good morning, one and all. In today's lecture, we will see in the MSc subject, mechanical system design. We will see the next bit, parameters in kinematic design of multi-speed gearbox. Okay, when you design, before going on that design, we require some parameters. Okay, in kinematic design of multi-speed gearbox. We will see that parameters, how to find out. First is we require the maximum spindle speed. Okay, first parameter we require maximum spindle speed. Okay, we have seen before previous lecture how to calculate or what is the spindle speed. It is denoted by the Nmax. It is denoted by the Nmax, maximum spindle speed. To calculate that maximum spindle speed, we have seen the cutting formula. Okay, V is equal to pi dn divided by 1000. This is the standard formula is given for the cutting. Okay, then we will convert this is in spindle speed. Then we will get n is equal to V into 1000 divided by pi d. Okay, this is the general formula for the spindle speed. Then when we get the maximum spindle speed, if cutting speed is maximum or diameter is maximum or minimum, both conditions we will see when we get the maximum spindle speed. If you have taken Nmax is equal to check that if you have maximum cutting speed and minimum diameter range, then we will get the maximum spindle speed. Okay, this is the first parameter in the kinematic design of multi-speed gearbox. All of you getting how to calculate this? We know the cutting speed formula, V is equal to pi dn divided by 1000. Then we will convert spindle speed is equal to V into 1000 divided by pi d. We want to calculate the Nmax, maximum spindle speed, and max is equal to 1000 into Vmax divided by pi d n minimum. Okay, cutting speed is maximum and diameter size is minimum. Then we get the maximum spindle speed. Second is a similar way, we want to calculate minimum spindle speed. Okay, how to calculate that minimum spindle speed? Okay, it is denoted by the N minimum. N minimum is equal to, again I will write directly, N minimum is equal to, check that this 1000 into this cutting speed is minimum. When we will keep cutting speed is minimum and diameter range is maximum, at that time we will get the minimum spindle speed. All of you getting? See, diameter range is maximum and the cutting speed is minimum, at that time we will get the minimum spindle speed. This is the second part. Then third we require the number of spindle speed steps. How to calculate that number of spindle speed steps? We know that it is denoted by the Z, number of spindle speed steps. Before going on that number of spindle speed steps, we require the range ratio value. How to calculate the range ratio and phi value? Already we have seen in the progression law, geometric progression law. Okay, number of spindle speed steps, it is denoted by the Z. Then what is the range ratio? I have already explained. What is the range ratio? It is the ratio, it is denoted by the Rn. It is the ratio of Nmax to N minimum. Okay, already we have calculated that maximum spindle speed and minimum spindle speed. Then put this value in this equation. Rn is equal to, you will get, what is this Nmax? 1000 into Vmax divided by what is this 5d minimum. Okay, if you have write here, I will write in the multiplication into 5d max divided by 1000 into V minimum. Okay, then see, if you have solved this, then this will be get cancelled, 5 get cancelled, then remaining I will write here V max divided by P minimum, check that, into D max divided by D minimum. Again, what is this V max divided by V minimum? Yes, V max divided by V minimum is nothing but the range of the cutting speed. It is denoted by the RV. Remember that. This is very important. RV is equal to, this is V max divided by V minimum. This is the range of cutting speed. Range of cutting speed. And what is the D max divided by D minimum? This is the RD. RD is nothing but the range of workpiece diameter. Range of workpiece diameter. Range of workpiece diameter. Okay, all of you getting how to calculate this Rn value, range ratio value. It is the ratio of n max to n minimum. Already we have find out the n max and n minimum. If you are putting in this equation, then you will get the Rv into Rd. Then you will get the new relation, Rn is equal to Rv into Rd is there. Rv into Rd is there. Okay, all of you getting how to calculate this? Then we want to calculate the number of spindle speed steps in the given gearbox. Okay, or multi-speed gearbox. I will erase this. Then see how to calculate this one. Yes, anybody? Do you know that we have seen the geometric progression law? We have the relation Rn. This is the Rn value is equal to Rv into Rd is there. But we have one more relation, Rn is equal to I raised to z minus 1. I raised to z minus 1. Okay, if you have simplified this formula, then knowing the value of Rn and phi, you will give the value of z. Z means what? Number of spindle speed steps. And how to simplify this? Check that. I will use z minus 1 into log 10 phi is equal to, I will write log 10 Rn is there. Okay, can I write in this format? Log 10 z minus 1 into log 10 phi is equal to log 10 Rn is there. Again I will write z minus 1 is equal to log 10 Rn divided by log 10 phi is there. Okay, if you have shift this z is equal to, again check that, again simplify, log 10 Rn divided by log 10 phi plus 1 is there. You can simplify this, z is equal to log 10, this is the equation number 1, I will write, log 10, check that, Rn plus log 10 pi divided by log 10 pi. Okay, or we can write again in the mathematics, z is equal to log 10, I will take the outside, then you will get the Rn into pi is there. Here is a summation means what? We will do the multiplication in the log and you will get the log 10 pi. Okay, this is the equation number 2. Guys, this is very important equation. Check that z is equal to log 10 pi, log 10 Rn into pi divided by log 10 pi. Knowing the value of Rn and pi, we will get the value of z. We will get the value of z. Or knowing the value of Rn and z, you will get the value of pi. Any one value. This equation is very much important equation. You should remember this equation. Okay, when you solving the numerical, then we will require this equation. Z is equal to log 10 into Rn into phi divided by log 10 phi. This Z value may be in the form of 2. 2 is there, 3 is there, 4 is there, 6, 9, 12 is there, up to the 36. Up to the 36. You will get the number of speed steps, total number of speed steps up to the 36. Okay, remember that. Yes, all of you getting? Then next step is the number of stages. Number of stages. Fourth number parameter is the number of stages. Okay. If you have designed the multi-speed gearbox, then you know the how many stages are there. Okay. Number of stages. It is denoted by what? Capital N. Or we can say the number of transmission route. Transmission route. Okay. It is also known as a transmission route. Number of stages of transmission route in the multi-speed gearbox, it is denoted by the capital N. Capital N. Okay. Then how to calculate that? We know the total number of speed steps. Z is equal to number of speed steps in the first stage and number of speed steps in the second stage. Okay. Up to the number of speed steps in the n stage. Okay. I will write here. Number of speed steps in the first stage, number of speed steps in the second stage, and number of speed steps in the third stage. Okay, all up to the nth stage. Nth stage. What is the P1? P1 is the number of speed steps. Number of speed steps in the first transmission route or in the first stage. First stage. Okay. Similar way. P2 is the number of speed steps in the second stage. Okay, and what is the PN? PN is the number of speed steps in the nth stage. Nth stage. Okay, this is the meaning of. Then we will give this equation in the equation number 3 is there. Okay, obtain this Z using the minimum number of gears. Okay, always remember that this Z should be obtained using the minimum number of gears. That's why we have choose the geometric progression law. Okay, remember that Z should be obtained using minimum number of gears, and all stages should have same number of speed steps. Okay, I have explained in the last lecture how to draw the structure diagram. Suppose here is I will give the example. Here is a 2 stages are there. 2 stages means how many shaft? 3 shaft is there. First, second shaft and third shaft. Suppose here is a you have given the numerical on the number of speed steps are 6. 1 is there, 2 is there, 3 is there, 4, 5 and 6 is there. Okay, this is the 6 speed steps. 6 speed steps. Okay, this is the 6 speed steps, and here is the number of stages. In between shaft 1 and 2, there is a first stage. First stage. In between second and third shaft, you will get the second stage. This number of stages here will get the 2 number of stages. 2 number of stages and 6 speed steps. What I have told, all stages, here is the 2 stages are given. All stages should have same number of speed steps. Same number of speed steps. Means check that. In the first stage we have the 6 speed number of speed steps. Again, here is the second stage we have the 6 number of speed steps. Okay. Means these are equal. Then all of you getting? Yes. Then next, these speed steps are same. Then we can write here P1 is equal to P2 is equal to Pn is equal to P is there. Is equal to P is there. Okay, this is the equation number 4. Equation number 4. Then can I write Z is equal to, with the help of this equation number 3, Z is equal to, here is a P1 is equal to P2, P2 is equal to Pn is equal to P. Then I will write here P into P up to the, here is a P, again P is there. Okay, can I write here in bracket n times. Okay, then we can simplify this equation. Z is equal to P raised to n is there. This is the equation number 5. Right, this is very important equation. You should remember, when you calculate the number of stages, then we require this equation. Z is equal to P raised to n is there. Equation number 5. Then again we can simplify this equation similar way. Here we have simplified Rn is equal to pi raised to z minus 1. Okay, then I will write here log 10, taking log both sides, log 10 z is equal to n into log 10 p is there. Log 10 p is there. And what is the n is equal to? N is equal to, yes, anybody? N is equal to log 10 z divided by log 10 p is there. This is also very important equation. When you calculate, I will erase this side. Okay, when you calculate the number of stages, then you know the formulae how to calculate the number of stages. Okay, with the help of these two formulae, equation number 5, and here I will write the equation number 6. Okay, these two equations are very important. Z is equal to P raised to n, and second equation, n is equal to log 10 z divided by log 10 p is there. Okay, these two equations are very important. Okay, when you are solving or find out the number of stages, then these two equations are very important. Check that the value of p is either, this value of p is either 2 or 3 in the transmission group, 2 or 3. This p value is either 2 or 3. When you are solving the numericals, we have seen the generalized formula. Z is equal to what? Z is equal to P1 into P2 into P3, or up to the Pn is there. Okay, total number of split steps. And you should choose the value of P is equal to 2 or 3. Why 2 or 3? Why 2 or 3? I will give the example. Check that if Z is equal to 6 is there, Z is equal to 6 is there, then 6 is equal to, I will put in this equation, we will use only 2 or 3. P1 is equal to or P2 is equal to. Okay, here is a, only this 2 is there. Okay, then you choose the P1 is equal to 2 and P2 is equal to 3. Or you can choose P1 is equal to 3 or P2 is equal to 2. You will get the 2 into 3, 6. Means 6 is equal to 6. This is the possible conditions. Okay. If you have choose the P1 is equal to 1, 2 or 1 or 2, then check that 1 into 3, 2 is there, 2. This you don't get the possible conditions. That's why this P is either only the 2 or 3. 2 or 3. Remember that. Okay. Then if the equation 5, check that if the value of the n obtained from the equation 6, okay, value of p n is obtained from the equation 6. If it is an integer value, if you don't get the integer value from the equation number 6, then you should modify the equation number 5. Okay, if you have not get the whole number, with the help of that equation, n is equal to log 10 z divided by log 10 p, then we want to modify this equation. Z is equal to p raised to n is there. Okay, we have what we can say, we have taken the 2-stage gearbox, 3-stage gearbox. We can't take the 2.5-stage gearbox. Okay, that's why we require the integer value. we require the integer value. Okay, if you are not getting integer value with the help of this formula n is equal to log 10 z divided by log 10 p, then we will modify this equation z is equal to p raised to n. Then we can write z is equal to 2 raised to n1 into 3 raised to n2. This is the equation number 7. This modify equation 5. Equation 5. Okay, z is equal to p raised to 1. I am putting p is equal to 2 and p2 is equal to 3. Then you will get z is equal to, or we can say n is equal to, how to get the number of stages, n1 plus n2. Remember that n1 plus n2. N is equal to, how to calculate the number of stages, n1 plus n2. n1 is the number of stages in the first stage, or we can say the with 2 speed steps. Okay, n1 is the number of stages with the 2 speed steps, and n2 is the number of stages with the 3 speed steps. 3 speed steps. Okay, all of you getting? This parameter we require before going on the design of multi-speed gearbox. Multi-speed gearbox. Okay, I will give the here one example. See, if we have given z is equal to 12, suppose. Okay, how to solve this? You can better understand with the help of example. Suppose if z is equal to 12 is there. If z is equal to 12 is there, put this value in that equation. Okay, n is equal to, I will put here log 10 z divided by log 10 z divided by z is equal to what? 12, and log 10 p is there, na? What is the value of p? Either 2 or 3. We will put first 2, then we will calculate with the help of calci. Log 10 12 divided by 2, you will get the 3.58. 3.58. This is an integer value? No, this is an not integer value. Okay, that's why this solution is not feasible. This solution is not feasible. If you are putting n is equal to 3, then check that n is equal to, sorry, p is equal to 3. Log 10 p 12 divided by log 10 p is there. If you have put this 12 divided by 3, then you will get the 2.26. Then you will get the 2.26. This is an integer number? No. Again, this is not feasible solution or not possible solution. That's why I have told, if you are not getting here integer number with the help of equation 6, then modify the equation number 5. Equation number 5. Then z is equal to what? 12 is there. We have modified equation z is equal to 2 raised to n1, 3 raised to n2 is there. Then check that with the help of this we can write this equation z is equal to 2 raised to n1 into 3 raised to n2. Here is a 12. 12 is equal to, we will put this value. 12 is equal to, check that, 12 is equal to, what I will put here, n1 is equal to 2 raised to what? I will put the 2, n1. Okay, 2 is there, 2 is there. Into 3 raised to, I will put the n2 is equal to 1. What is the value of n1 and n2? n1 is equal to 2 and n2 is equal to 1. I have put here n1 is equal to 2 and n2 is equal to 1 is there. Okay, then check that 12 is equal to 2 raised to 2 means what? 4, and 3 raised to 1, 3. 4 into 3, 12 is equal to 12. This condition is satisfied. This condition is satisfied. If we are putting here number of stages with 2 speed steps. Here, if you have put the 3, 2 raised to 3, what you will get? 8. 8 into 3, 24 is there. Okay, this condition is not satisfied. 12 is equal to 24. This condition is satisfied? No. That's why you have to put this value those values are same or equal. Okay, that's why I have putting here 2 raised to 2 into 3 raised to 1. Then we know that the formula n is equal to n1 plus n2 is there. n1 plus n2 is there. N is equal to, what is the n1? 2 plus 1 is equal to 3. This given gearbox, if you have given z is equal to 12, then how many stages are there? N is equal to 2 plus 1, means there are 3 stages. There are 3 stages. All of you getting? You can better understand with the help of this example. Then last is a speed of the electric motor. Okay, one more parameter will require speed of the electric motor. We have seen already, if you want to the single speed drive, okay, or speed, then we are using the electric motor. Okay, last is a speed of electric motor. Speed of electric motor, it is denoted by NEM. Okay, we have seen already the speed of the electric motor or shaft to the gearbox. Okay, required speed of the input shaft of the gearbox, required speed of the input shaft of the gearbox is equal to the electric motor speed. Okay, this electric motor are directly connected to what? This electric motor are directly connected to the input shaft. Input shaft. Okay. This electric motor is directly connected to the input shaft. Both electric motor and input shaft speeds are same. Okay. This is the single speed drive. We want the multi-speed gearbox. If you want the multiple output, okay, then we want to change the speed of the input shaft. Okay, then what we will do, we want to connect to change the speed of the NEM to the input shaft. How to change this speed? We want to use here belt drive, we want to use the gears. Okay, this is in NEM, speed of the electric motor. Okay, we want to change this speed or reduce the speed, then we want to use the belt drive or we want to use the gear arrangement. Okay, it required the different speed of the input shaft, then we want to do this arrangement. Okay, if you want the same speed, then don't do this arrangement. Okay, all of you getting how to calculate or how to find out the parameters in kinematic design of multi-speed gearbox. That 5 parameters are very important when you solving the numerical. That's why you should remember that parameters. Next lecture we will see the remaining part of the first unit. Today we will stop here. Thank you.